All right. So today, for today's notes, we are going to talk about this idea of scaling. So for today's notes, we are going to write 8.4 multiplication as scaling. And I'm going to put quotes around the word scaling because that's a new term, and I want to make sure we start to talk about what it means. So let's start there. I'm going to zoom in and focus on this page. And let's start with this new word, scaling. Scaling means multiplying to make something bigger or smaller, or to increase or decrease the amount. So multiplying to increase or decrease the size or amount. So let's do a little picture to kind of explain what we mean by this. I'm going to start with this idea of a square. Well, almost a square. Now, if I multiplied the amount that this square represents by 2, if I did times 2, I would end up with a bigger square overall. It would get bigger. Now, if I did the opposite, if I multiplied by 1/2, it would get smaller. I'm scaling, multiplying in different ways to increase or decrease the amount. Let's grab our crayons and let's color that in. I'm going to say, here's my original starter amount. And when I multiply by 2, it got bigger. And when I multiplied by 1/2, it got smaller. I was scaling. Now, the goal of this unit is to be able to look at some different situations and to figure it out using our logic, to figure out, do I expect this to get bigger or smaller? Is this going to increase or decrease? And I want to figure it out by thinking about the numbers involved. So let's do a little exploration. Let's start with the number 3. Actually, let's start with the number 2. And I'm going to say 2 times 1/3. What happens if I multiply 2 by 1/3? And then I'm going to try 2 times 2/3. And then 2 times 3/3. And 2 times 4/3. And then let's do 2 times 5/3. And I'm going to zoom in a little bit. There we go. So let's just start solving these using our multiply a whole number by a fraction skill. So starting up here, 2 times 1/3, my strategy is to rewrite 2 as a fraction by 2/1 and multiply it by 1/3. 2 times 1 is 2. 1 times 3 is 3. I get 2/3. And that's really interesting because I started off with 2 and I ended up with 2/3. The number I started with was 2, and I multiplied it by 1/3, and it got smaller. 2/3 is definitely smaller than 2. So let's try another one. Now I have 2 times 2/3. So I'm going to start by writing 2 as a fraction, 2/1, and multiply it by 2/3. 2 times 2 is 4. 1 times 3 is 3. 4/3. Well, that's an improper fraction. Okay. Well, I have enough to make one whole number and have 1/3 left over. 1 and 1/3. So if I started with 2 and I multiplied by 2/3, I ended up with 1 and 1/3, which once again, it got smaller. Let's start with 2 times 3/3. I can write my 2 as a fraction, 2/1 times 3/3. 2 times 3 is 6. 1 times 3 is 3. 6/3. Well, 6 divided by 3 is 2. So that one's really interesting. I started with 2, and when I multiplied it by 3/3, I ended up right back at 2. Well, that would make sense because 3/3 is the same thing as 1. And whenever I multiply something by 1, it stays the same. So it looks like so far my fractions either get smaller or stay the same. Let's see if that pattern continues. Now I have 2 times 4/3. I'll write my 2 as a fraction times 4/3. 2 times 4 is 8. 1 times 3 is 3. Ooh, another improper fraction. All right. If I do 8 divided by 3, that gives me 2. And I have 2 left over, and they're thirds. 2 and 2/3. Well, interesting. Now I started with 2, but when I finished multiplying, I ended up with 2 and 2/3. I actually ended up at a bigger number than I started out. Let's look at the last one, 2 times 5/3. I can write 2 as a fraction, multiply it by 5/3. 2 times 5 is 10. 1 times 3 is 3. Now I've got 10 divided by 3. That's like 3 and 1/3. So for this one, I started at 2. I multiplied it by 5/3, and I ended up at 3 1/3. This one got way bigger. So now let's go back and let's look at the factors. What did I multiply 2 by? In the first one, I multiplied 2 by 1/3. And the second one, I multiplied by 2/3. In the third one, I multiplied by 3/3, which we talked about is the same as 1. In the fourth one, I multiplied by 4/3, and then by 5/3. And I noticed something. I'm hoping you did too. In the first 2 problems, I multiplied by a factor less than 1. In the first one, I multiplied it by a factor of 1/3. In the second one, I multiplied by a factor of 2/3. Both of those fractions represent a number less than 1 whole. It's not a full anything. In the third one, I multiplied by 3/3, which is a factor equal to 1. 3/3 is exactly 1. And in the last set, I multiplied by a factor that is greater than 1. 4/3 is greater than 1, and 5/3 is also greater than 1. The big idea here is if I look at the first problem, 1/3 is less than 1, and when I multiplied by it, I ended up with a result that got smaller than the original number of 2. In the middle one, I multiplied by a factor that's equal to 1, and the result was that the end result stayed the same. And in the last 2, I multiplied by factors that are greater than 1, and I ended up with results that were greater than my starting amount of 2. So here's the big takeaway. Let's move my page up. When multiplying by, so when I'm multiplying by a factor less than 1, the result gets smaller. My example was 2 times a factor that's less than 1 will give me an answer that's smaller than my starting number of 2. When I multiply by a factor greater than 1, the result gets bigger. And when I multiply by a factor equal to 1, the result stays the same. So let's go ahead and color code that info. Let's grab our highlighter. So our original factor in our examples was 2, so I'm going to color the word factor. When I multiply by a factor that is less than 1, we used pink for that, the result gets smaller. When we multiplied by a factor that was greater than 1, the result gets bigger. I guess I could have used the word greater there. And when we multiply by a factor equal to 1, the result stays the same. All right, this is the big idea. Go ahead and move on to your practice problems to see this skill in action, and then you'll be ready to try some on your own. Good luck!